Today we're going to be learning how to find the equations of linear graphs. When you need to find the equation of a diagonal line, you need to remember that the standard form of the equation is y equals mx plus c, and we're going to follow 3 steps to find the equation. The first step is to find the gradient, which is the m in the equation. The second step is to find the y-intercept, which is the c in the equation, and then we're going to go and put those two values, once you've found both of them, into the equation and write the equation in the form y equals mx plus c. If you need to find the equation of a horizontal line, you need to remember that the equation is going to be written in the form y equals a, where a is a number. To identify when you're going to have a line with this kind of equation, it's when you have a straight line with 2 or more points that have the same y value, and that y value will be the a that you're going to put into your equation. Or if you have a straight line that you're being told is parallel to the x-axis, then the y value of any point in that line will be the a value in your equation. Then if you need to find the equation of a vertical line, it works very similarly to a horizontal line, except that the equation is going to be x equals b, where b is a number. Again, to identify it, it's when you have a straight line with 2 or more points that have the same x value, and that x value will be the b that you're going to put into your equation. Or if you have a straight line that is parallel to the y-axis, then the x value of any point on that line will be the b value that you're going to have in your equation. Now let's go and have a look at an example where we're going to practice finding the equations of linear graphs. Okay, so in this question, we need to find the equation of this graph where we've been told that the y-intercept is 6 and the x-intercept is -2. Let's go and have a look at how we would do this question. So the first thing I need to do to find the equation of this graph is I need to find the gradient of the graph. So to find the gradient, I'm going to use the formula m equals y2 minus y1 over x2 minus x1. Okay, now that means that I need a point 2 for the y2 and the x2, and I need a point 1 for the x1 and the y1. So I'm going to choose which point over here I'm going to make point 1 and which point I'm going to make point 2. But first I'm just going to write these as coordinates, so it's going to be easier for me to actually see what the x and y values are for each point. So the coordinates of this point over here are 0, 6, and the coordinates here are -2, 0. Now I prefer to have any negatives in point 2 if possible, because it makes it easier when I'm subbing it in here and working it out. So I'm going to make this point 2 and this point 1. I could do it the other way around. It just makes it a little bit easier if the negatives, if there is only one point with negatives, I prefer to make it point 2 because I'm not subtracting the negatives in my formula. Okay, so over here I'm going to go and sub that in. So I've got for point 2, y2 is going to be 0 minus y1, which is 6, over x2 is -2 minus x1, which is 0. So now we're just going to simplify that. So I've got 0 minus 6, that's -6, over -2 minus 0 is -2. -6 divided by -2 is +3. So my gradient is 3. The next thing I need to do is find out what my c value is. Now remember, the c value is the y-intercept. Now in this graph, they've told me what the y-intercept is by showing me that it passes through 6 on the y-axis. So my c value is equal to 6. So now I know my m value, that's my gradient, and I know my c value from my y-intercept. So now I can go and put that into the equation in the form y equals mx plus c. So I can say, therefore, my equation for this graph is y is equal to m, which is 3, x, and then plus c, so that's plus 6. So that is the equation for that linear graph over there. Okay, now I'm going to give you a few that you're going to do for yourself to practice this. Here's the first one that you're going to do. I'm going to give you 1 minute to find the equation of this graph. Okay, so let's go through that question and see what you should have got. Right, so the first thing I'm going to do here is I need to find the gradient of this graph. Now, to find the gradient, I'm going to use the formula m equals y2 minus y1 over x2 minus x1 again. Now I'm going to write down the coordinates for each of these points over here, so it'll be easier for me to fill them into the formula. So the coordinates of this point are 0, 3, and this point has the coordinates 3, 0. Now, neither of those has any negative value, so it doesn't matter which one I make 0.1 and which one I make 0.2. So I'm just going to make this one 0.1 and this one 0.2. Okay, so when I fill it into my formula, y2 is going to be 0 minus y1, which is 3, over x2 is 3 minus x1, which is 0. Okay, so now we're going to go and simplify this. So this gives me negative 3 over 3, which simplifies to give me negative 1. So my gradient is negative 1. So that's the m value for my equation. Now I need to find the c value for the equation. So the c value is going to come from my y-intercept, which they've told me over here is 3. Okay, so that's going to be c is equal to 3. So now I can go and fill that in and write it down for the equation of this graph in the form y equals mx plus c. So y is equal to m is negative 1x, which I can just write as negative x. Okay, so that's y equals negative x plus c, and c is 3, so that's plus 3. So your equation for this graph should have been y equals negative x plus 3. Right, let's go on to the next one. I'm going to give you 1 minute to find the equation for this graph as well. Okay, so let's go through that and see what you should have got. Right, so once again, my first step is going to be to find the gradient for this graph. So my formula m equals y2 minus y1 over x2 minus x1. Okay, so I'm going to put in my coordinates. So this point is the coordinates 2, 0. And this one has the coordinates 0, negative 4. And because this one has a negative value, I'm going to make it 0.2. And this is going to be 0.1. Okay, so now let's go and fill those into the formula. So y2 is negative 4 minus y1, which is 0, over x2 is 0 minus x1, which is 2. Okay, so that gives me negative 4 over negative 2, which simplifies to give me positive 2. So my gradient for this linear graph over here is going to be 2. The y-intercept, which is my c value, they've told me over there is negative 4. So c is equal to negative 4. So now for this linear graph, my equation is going to be y is equal to m is 2, so it's 2x, and then plus c, which is negative 4. So that's going to be minus 4. So that's what we should have got for question B. Y is equal to 2x minus 4. Right, let's go on to question C. Let's give you 1 minute to find the equation of this graph as well. Okay, so let's go through that question and see what you should have got. Right, so for this question over here, I have a graph that goes through the origin. The coordinates of the origin are 0, 0. And it also goes through the point 5, 2. So now I'm going to choose to make this point 2 and this point 1. Anytime that your graph goes through the origin, I recommend making the origin point 1 and the other point 2, because it'll make it easier for you to find the gradient. Okay, so over here I'm going to go and fill that in. So my y value for point 2 is 2, so that's going to be 2 minus 0 over 5 minus 0. So that gives me 2 over 5. So I don't need to worry about the zeros because they don't do anything, so I can just drop them and it gives me 2 over 5. So my gradient for this graph is going to be 2 over 5, and my c value is 0 because it goes through the origin. So now when I write this down for my equation, I'm going to have y equals, the gradient is 2 over 5, so it's 2 over 5x. And then I would normally write plus c, but because c is 0, because it goes through the origin, I'm not going to write plus 0. So it's just y equals 2 over 5x. Anytime that your graph goes through the origin, when you have a linear graph, when it goes through the origin, you're not going to have a c value. So it's just going to be y equals something x. Okay, right, let's go on to question D. I'm going to give you 1 minute for this one as well. Okay, so let's go through that question. Right, so I'm going to start off by writing these down as coordinates. So this point is point 0, 4, and this is the point 12, 0. I'm going to choose to make this one point 1 and this one point 2. It doesn't really matter which way around you do it because neither of them has any negative values. Okay, so now I'm going to go and fill that into my equation. So I've got y2 minus y1 is going to be 0 minus 4 over x2 minus x1 is going to be 12 minus 0. Okay, so that gives me negative 4 divided by 12, which is negative 1 over 3. So my gradient for this graph is negative 1/3, and then my c value is the y-intercept, which is 4. Okay, so now we can go and fill that in and make that our equation. So therefore y is equal to m, which is negative 1/3, x, and then plus c, which is 4. So that's plus 4. So that's what you should have got for question D, that the equation for this linear graph is y equals negative 1/3 x plus 4. Right, let's go on to our next example. Now this is a different kind of graph. It's also linear, but you can see that it doesn't have an x-intercept. It goes through the y-axis at 7, and it goes through the point negative 4, 7. So this is an example of a horizontal graph. It has 2 points where the y value is the same. They're both 7. Okay, so let's have a look at how we would get the equation for this graph. Okay, so for this graph over here, remember when you've got a graph that is horizontal, so it's parallel to the x-axis, and it has more than one point that has the same y value, or if they show you that it's parallel to the x-axis, then you're going to have an equation in the form y equals a number. Okay, so it's going to be y equals, and then the number is going to be the same number that we have for the y value where it goes through that y-axis. So over here, it's going through the y-axis at 7, and you can also see that the y value here is 7. So that means that because this is a straight line, everywhere along this line, the y value is going to be 7. Because I've got 2 points where I have the same y value of 7, it means that y is always going to be equal to 7. So my equation is y equals 7. So when you get a graph where you have 2 points, it's a straight line, you have 2 points, and they both have the same y value. It looks like it's horizontal, and they both have the same y value. Your equation is going to be y equals that y value. There's no x in the equation because this has got a 0 gradient. The gradient is 0 because it's flat. Okay, so that is what we get for the equation for that graph. Now I'm going to give you a couple to do for yourself. So I need to give you 30 seconds to find the equation of this graph. Okay, so let's go through that question quickly. So for this one, it's not a horizontal line. This time it's a vertical line. But you can see again, because it's a straight line and it goes through 2 points, but this time the x-intercept is -3 and the x value of the other point is also -3. So the graph is going through 2 points with the same x value of -3. So our equation for this graph is going to be x equals that x value of -3. Because it's a straight line, if there are 2 points with the same x value, it means that everywhere on that line, the x value is going to be that same value. So everywhere on this line, x is going to be equal to -3. So our equation is x equals -3. Okay, let's go on to the next question. I'm going to give you 30 seconds to find the equation of this graph as well. Okay, so let's go through that question. So in this one, it looks a little bit different to the previous two because I've only been given 1 point on this graph. I've been told that it's passing through the y-axis at -4, but I haven't been given another point. So I haven't been told that the y value at another point is also -4. However, I have been told that this line is parallel to the x-axis, which means that it is a horizontal line. So even though I haven't been told that the y value at another point is -4, because I've been told that these are parallel, it means that the y values at all points on this line will be the same as each other. So that means I can write my equation over here for question B as y equals -4. When you have lines that are horizontal, they will cut through the y-axis. It's going to be y equals something, a number. When you have a line that is vertical, it cuts through the x-axis, so it's going to be x equals a number. When you've got a horizontal or vertical line, it can sometimes be confusing about if you're going to make it y equals or x equals. Don't make it the one that is parallel to. Make it the one that it cuts through. So it cuts through the y-axis, so it's y equals. Or if it cuts through the x-axis, then it's x equals. Okay, so over here it's cutting through the y-axis, so it's y equals. And it'll be y equals the number where it cuts through the y-axis. Or if I had been given a different point on this line, so if I was given the coordinates of a point, not the y-intercept, but a different point, because it's cutting through the y-axis, I use the y value of that point. Okay, right, let's go on to our next example. Okay, so in this question, I need to find the equation of the graph again, but this time I haven't been told what the y-intercept is. I've been told the x-intercept is -4, and I've been told that the graph passes through the point -1, -6. Okay, let's have a look at how we do this question. So once again, I need to start off by finding my gradient first using my formula y2 minus y1 over x2 minus x1. Again, I need to write this point over here with its coordinates of -4, 0. It's going to make it easier when I put it into my formula over here. And I need to choose which point I'm going to make point 1 and which one I'm going to make point 2. Now in this case, it doesn't really matter which one I make point 1 and point 2 because they both have negatives, which means I can't avoid subtracting a negative. So either way, I'm going to end up subtracting a negative. I'm going to make this point 2 and this point 1. This way, at least I'll be subtracting only one negative instead of subtracting two negatives, but I'm still going to have to subtract negatives. Okay, so when I fill my values in here, y2 is going to be -6, and then I've got minus y1, which is 0, over x2 is -1, and now I've got minus x1, which is -4, but because I'm subtracting a negative, I need to put this in brackets. Okay, I didn't have to put it in brackets over there because it wasn't minus a negative, it was just minus a normal number. Okay, so I'm going to have to go and simplify this. So this over here gives me -6 minus 0 is -6, but at the bottom I've got -1 minus -4, that gives me +4. So I still have to simplify that over there. So I have -6 over -1 plus 4 is +3. So -6 divided by 3 gives me -2. So my gradient for this line is -2. So I know that so far. But now, normally I would now write c equals whatever the y-intercept is, at least in the ones we've done so far. But in this case, I haven't been told what the y-intercept is. So I can't just write it down. So what I now need to do is I need to work out what the y-intercept is. So what I am going to do is I'm going to write down what I know so far for the equation. So I'm going to write the equation as y equals -2x, and then I'm just going to write plus c because I don't know what c is yet. Okay, so that's what I know so far. Now what I need to do is I need to go and work out what c is. So to work out the value for c, I'm going to look at my graph and I'm going to see what can I use to help me to find out what c is. Now the graph goes through 2 points. It goes through this point and it goes through that point, and each of these points has got an x value and a y value, which are paired together. As long as I stick to an ordered pair, so as long as I use an x value and a y value of a point that is on this line, I can take that point's x and y values and I can put them into this equation. I can replace the x and y with the x and y values of a point on the line, and then if I replace the x and y values, it means I'll only have one unknown left, which is that c. Then I can go and solve for c. So I'm going to choose one of these 2 points. It doesn't matter which one I do. And I will actually show you with both of them in this example. So if I use the point -4, I'm going to sub in -4, 0. And I will get this over here. So my x value is -4, my y value is 0. So in the equation, I will have 0, which is the y value, equals -2 times the x value, which is -4, plus c. So now I took the equation that I had over there and I substituted in the x and y values of one of the points that is on that line. And now I can go and solve for c. So I've got 0 equals -2 times -4 is +8, plus c. If I want to get c on its own, I'm going to get rid of that 8 on the side over here by subtracting on both sides. So that's -8 equals c. So now I know what my c value is. c is -8. So if I take that and I put it into the equation, I can now say, therefore, y is equal to -2x, because my gradient was -2. So -2x, and then plus c is now going to be -8. Okay, so that's if I substituted in this point over here. But now I had another point that I could have used as well. I could have used this point over here. As long as I'm using a point that is on the graph that I'm working with, I can substitute the x and y values into that equation. I can't use another point somewhere else that is not on this graph. But as long as it's on the graph, I can use the coordinates for that point. So this point over here has the coordinates -1, -6. So I could also have used that point. So if I used that point, it would have looked like this. So I'm using the same equation over here. My y value is now -6 equals -2 times x is -2 times -1, and then plus c. So I've got -6 equals -2 times -1 is +2 plus c. If I take this 2 and get rid of it and we subtract on both sides, that's going to be -6 minus 2 is -8 equals c. So I got the exact same value for c, which means that I would get the same equation. So therefore y is equal to -2x and then -8. Okay, so it doesn't matter which point you use. I could have used this one or I could have used that one. I would end up with the same equation. You obviously don't need to do it for both points. You choose a point and then you can substitute it in to find your c value. So when you haven't been given the y-intercept and you've been given two other points, you first find your gradient in the same way as normal, and then you take one of the points that you've been given and you substitute it into the equation to find your c value so that you can then write down your equation like that. Yes, now I'm going to give you a couple of these to try for yourself. I'm going to give you 2 minutes to find the equation of this graph. Okay, so let's go through that question and see what you should have got. Right, so we're going to start off by finding our gradient like normal using the formula y2 minus y1 over x2 minus x1. I'm going to choose to make this 0.2 because it has a negative and this one doesn't have a negative, and this will be 0.1 over here. Okay, so when I go and substitute this in, my y2 is going to be 10 minus y1, which is 2, over x2 is -3 minus x1, which is 5. Okay, so now we can go and simplify that. So I've got 10 minus 2, that's 8, over -3 minus 5 is -8. So I've got 8 divided by -8, that gives me -1. So my gradient for this graph is -1. Now, I haven't been told what the y-intercept is, so I can't just write down c equals something and fill it into my equation. So now I need to go and work out what my C value is. So first I'm going to write down what I already know. So I've got y equals negative 1x, which is just negative x, and then plus c. I don't know yet what c is, but I can go and work it out by taking either one of these 2 points. Remember, it doesn't matter which one you use, as long as you're using a point that is on the graph that you are working out the equation for. So I can use negative 310, or I can use 5, 2. I can't use any other point that is not on that line over there. So I'm going to go and sub in. It doesn't matter which one I choose. If I choose the negative 310, it'll work, and if I choose the 5, 2, it'll work. I'm going to use 5, 2 because it doesn't have any negatives, so it'll be a little bit easier to work with. But if you chose negative 310, it would work as well. So I've got 5, 2 over there, and I'm just going to sub that in. So I've got y is 2 equals negative 5 plus c. Okay, so now I'm going to go and solve for c. So over here, I've got 2 plus 5, that gives me 7, equal to c. So now I know what my c value is. So I can go and put it into my equation. So my equation is going to be y equals negative x, and then plus 7. Okay, so that's what you should have got for question A. Right, let's go on to question B, which is the last one for today. I'm going to give you 2 minutes to find the equation of this graph as well. Okay, so let's go through that question and see what you should have got. Right, so first of all, I'm going to find my gradient using the formula y2 minus y1 over x2 minus x1. So I need the coordinates of point 2 and the coordinates of point 1. So over here I've got a set of coordinates. Here I'm going to write this as a set of coordinates again, so that's 4, 0. I'm going to make this point 2 and this point 1 because this one has got negatives and that one doesn't. Okay, so now let's go and fill in our values. So y2 is negative 6 minus y1, which is 0, over x2 is negative 8 minus x1, which is 4. Okay, so that gives me negative 6 minus 0 is negative 6 over negative 8 minus negative 4 is negative 12. So I've got a negative divided by negative is positive, and then 6 over 12 simplifies to 1/2. So my gradient for this graph over here is a half. So far I know that y is equal to half x plus c, but I don't know what c is because they haven't told me what the y-intercept is. So now I need to go and choose one of these points and substitute it in to find out what c is. So again, it doesn't matter which one you use. I'm going to use the point 4, 0, but you could have used -8, -6 if you wanted, and that would be fine too. Okay, so I'm going to go sub in the point 4, 0, and I'm going to go and fill that in to my equation over here. So the y value is 0, so I've got 0 equals half times the x value, which is 4, plus c. Okay, so now half times 4, this is 4 over 1. You can't see it, remember, but it is over 1. So I'm multiplying, so I can cancel out my denominator with the numerator. So 2 goes in there once, 2 goes in there twice. So half times 4 is 2. So I've got 0 equals 2 plus c. Now I can go and solve for c, so that means that c is equal to, if I take this, get rid of the 2 on this side, I'm going to subtract on both sides, so that's -2. So c is equal to -2. So now I can go and put that into my equation. So I can say, therefore, y is equal to half x minus 2. So that you should have got for that question, that y is equal to half x minus 2. And that's how you find the equations of linear graphs. Now that we've learned the concepts in this lesson, it's important to practice, practice, practice. If you haven't already got the worksheet that goes with this video, you can find it by clicking on the link in the description below. The worksheet comes with an extra exercise full of questions for you to work on to master the concepts covered in this lesson. If you found this video helpful, please hit the like button so that others can benefit from it too. Also, be sure to subscribe so that you can easily find my other lessons, and hit the bell so that you will get notified about lessons as I upload them.